Hello everyone. So today we're going to go over section 2.4, the sine and cosine ratios. So here we're going to calculate the length AB and use it to complete the table. So we have a squared plus b squared equals c squared. And in this case, we have the length AC squared plus the length BC squared, which will be equal to the hypotenuse AB squared. So of course, AC has length 2, BC has length 1, and on the right-hand side, we have AB squared. So 2 squared is 4, 1 squared is 1, so 4 plus 1 gives us 5, is equal to AB squared. And that the length AB will be equal to, as a radical, the square root of 5. So the hypotenuse for the triangle ABC, which is length AB, is the square root of 5. For ADE, the next triangle, notice that we have square root 5 and then another square root 5, so that will be effectively just 2 times the square root of 5, or 2 root 5. Likewise, for AFG, we have 1, 2, 3, square root of 5. And finally, for AHI, it will be 4 root 5. The side opposite the angle A, so BC has length 1, DE has length 2, FG has length 3, and HI has length 4. So 1, 2, 3, and 4. And the adjacent side has length 2, 4, 6, and 8, respectively. So if we take the side that's opposite angle A and divide it by the hypotenuse, in the first case, we'll have 1 divided by the square root of 5. Like so. So that will be 0.447 approximately. Followed by 2 divided by 2 times the square root of 5, which of course will give us the same value of 0.447. In fact, since the angle A stays the same and all the triangles are similar, the side opposite angle A divided by hypotenuse will remain the same for all 4 of these nested triangles. Likewise, for the side adjacent to A divided by the hypotenuse, we'll simply have 2 divided by the square root of 5 for this first one. And once again, the rest of the ratios will be the same. So approximately 0.894. The first ratio is called the sine ratio, opposite divided by hypotenuse. And the second ratio is known as the cosine ratio, adjacent divided by the hypotenuse. Okay, so once again, the definitions are given to us here And here as well. And our usual shorthand for these are sine A is equal to opposite over hypotenuse and then cosine A is equal to adjacent divided by hypotenuse. So with the tangent, sine, and cosine ratios, those three are collectively known as the primary trigonometric ratios. The word trigonometry comes from three Greek words that together mean three-angle measure. Look at some examples for the use of the cosine and sine ratios. The first one we have here, we're going to find the cosine of angle C. So cosine C is equal to adjacent over hypotenuse. Which would just be 6 over 8. We'll then use the inverse cosine function on our calculator to get C is equal to inverse cosine of 6 over 8. And once we evaluate this, we'll get angle C. So inverse cosine 6 divided by 8 gives us approximately 41 degrees. So next up we have angles D and E inside of DEF. So let's start with angle D. Opposite side is EF. Adjacent side is the 4. And the hypotenuse is 8. So it makes sense for once again for us to use the cosine ratio. Cosine D is equal to adjacent over hypotenuse so cosine D is equal to 4 over 8. So D is equal to inverse cosine or arc cosine of 4 over 8. Which is equal to, let's use a calculator, inverse cosine 4 over 8, which is 60 degrees. So to find angle E, we can simply use the fact that angles D and E must add up to 90. Just go 90 degrees minus 60 degrees from angle D, which leaves us with 30 degrees for angle E. We can also use the sine ratio to find angle E as well. Note that from angle E, we have the adjacent side EF and the opposite side of 4. So sine E is going to be equal to 4 over 8 as well, since the opposite side from angle E is 4, and the hypotenuse is 8. So E is going to be equal to inverse sine or arc sine of 4 over 8. And on the calculator, this gives us 30 degrees as well. Okay. Let's look at one more example. So see, a water bomber is flying at an altitude of 5,000 feet. Let's go ahead and draw a diagram of that, 5,000 feet. This radar shown is 8,000 feet from its target. So should have a right triangle that looks like this. Altitude is 5,000. This is the water bomber. Okay, we have the angle of elevation here. We'll call it A. And of course, this is the target. And the distance from the water bomber to the target is 8,000 feet, measured in a straight line. So we can see that this is an example of using the sine ratio. Since sine A is going to be equal to opposite, which is 5,000, divided by the hypotenuse, which is 8,000. So again, opposite over hypotenuse. Then we can substitute in the two sides that we know. And of course, A is going to be then equal to inverse sine or arc sine of simply 5 over 8. Since we can divide both 5,000 and 8,000 by 1,000. And so A is going to be equal to, and we're going to round to the nearest degree again. So 39 degrees. So here we looked at today the sine and cosine ratio and used them to find angles that involve the hypotenuse being given to us. And that's it for today. So thank you for listening.